Okay, so today we're going to look at one of the formulas for finding the area of an oblique triangle. So this is not a right triangle, so we can't use, like sine and cosine in the traditional sense that we would do that. We have to kind of break these into right triangles so that we can use our information about the trig. So I did that, and again, I usually draw just this little like scalene acute triangle situation here. But I drew this one just so that you could see that it actually works. Because I always say, oh, it always works. You can draw it with the height on the outside. But just in case you didn't know what I was talking about, this is what I'm talking about. You can draw it so that the height is out here, and we have this big obtuse angle. So it works with an obtuse triangle also is what I'm trying to get at. Okay, so it really doesn't matter which way that you think about it. You can do it either way. It's going to work out. But for the sake of the thing, we'll just look at this one because whatever. I think this is the easier one for us to look at. So I think this is the one our brain understands better. So we'll just look at this one for today. Okay. So again, we all know that the area of a triangle, we learned this when we were young people, right? It's 1/2 the base times the height, or, base times height over 2, or however you learned it. I don't know. So the way I drew the triangle, obviously this is the base and this is the height, but everybody knows, this doesn't have to be the base. Like this could have been the base and this could have been the height. You can do it any way that you want. It doesn't have to be the one that's perpendicular to the bottom of parallel to the bottom of the page. It doesn't have to be the base, but that's, again, just because it's easier for our brain to see it, that's the way I drew it. Okay. All right. So we know this is true. So let's take a look at this triangle for a second and let's see if we can say anything to maybe get some trig in there. So again, there's a couple things we could say. If I'm looking at angle A here, right, we could say that the sine of A, let's say sine A is equal to H over B. Would that be fair? Or in other words, B sine A is equal to H. So remember, I'm going to put this in this box here, or this little cloud, because I want you to remember that B here equals base, and H here equals height, and A here equals area, which is not what it equals in this triangle. Okay? This over here is actually side B, and this is actually H, which H and H actually mean the same thing here and here. Okay? So don't get confused because you're looking at this. All right? All right. So let's take a look at this now. What else could I say? Well, we could say if we had B here, we could say that sine B is equal to H over A, or A sine B is equal to H. We could say that also, right? We could. How do you feel about that? We good? All right. So then if we agree on that, then let's just take one last look at this triangle. I know that this is, if I'm calling this one the base. Everyone agree with that? So let's go back to this area formula here. The area of the triangle is equal to 1/2. The base in this case I'm calling is C. Does everyone agree with that? So the B in this one is actually C in my triangle. Are we okay with that? Okay. Now, here's where the fun starts to begin. We can see that H here, I can either replace it with A sine B, or I can replace it with B sine A. It really doesn't matter which one I replace it with. But I'm going to replace it with this first one. I'm going to replace it with B sine A. So here, right, is this guy. And this one is actually this guy here. And this actually is the area of this triangle. So instead of having to know the height and the base, I can know something about this angle and two sides in the triangle, okay? B and C in this case. All right, so when would we use this? Well, I don't know. Let's see. Let's say we have find the area of a triangle whose two sides are 90 meters and 52 meters. And the included angle is, I don't know, we can call it whatever you want. We'll call it 100 degrees. Okay? So could this be a possibility that we know something like this? It's a possibility. Like, what does that mean? It means we know this and this, right? So we would know that this one's, I guess that one would be the 52. Oh, sorry, 52, and this one would be the 90, and we know that this is 100, right? Is it possible to know this information? And we don't even need to know this side, right? We could find the area of this space. So this information is given, this is given, and then this angle. So that seems like a likely thing that we could possibly know about maybe a triangular plot of land or whatever. Whether we would ever have a triangular plot of land or something, that's the tricky one. You know, like I don't know when that would ever come up, but it is a possibility, right? We could know these three things rather than the three sides. Like, I don't know, let's say there's a lake here that's sort of triangular shape, and we're trying to estimate the area of the lake, right? And we're on this side of the lake, and we don't know what that side is or something. You know, I don't know. But in any case, here we are in this situation where we know these two sides and this included angle. So the area of the triangle is going to be 1/2. Well, it doesn't matter which one I call C and which one I call B. And this is, of course, going to be my angle A in my formula. So it's going to be 52 times 90 times sine of 100 degrees. And how would I figure out such a thing? Well, this is where I would go to my calculator. If it was an angle that I knew, I could do it in my head, but I don't know that angle. I don't know about you. Sine of 100 is not one that I'm familiar with. So how would I do this one? I do 0.5, or you could do 1 divided by 2, of course. But I'm not going to do that. Sine 100, and then I'm going to just check because other people use my calculator, so I'm hitting the mode button, and we can see that my calculator is in radians right now because we're more likely to use radians than degrees when we're doing trig, right? But for law of sines and cosines, a lot of times we're doing degrees, so I'm making sure that it's in degrees, and then I'm going to quit out of here because I'll get a completely different answer if I'm using radians than if I'm using degrees. So that would be, what would be my units? Well, it's meters times meters, right? This was meters and this was meters, so obviously this is meters squared, would be my area of the triangle. Okay, so this is a formula that we can use to find the area of a triangle. If we don't know the height, we know the length of two sides, and we know the included angle instead. Okay, and that's a very popular thing. You know, like when you have a triangle like this, how do you find this height? Sometimes we can't. So having two sides and an angle is a more likely situation. Okay, so there's your area of an oblique triangle.